All right, hello everyone. What is up? All right, so this is the day after the review day, the day before the quiz, okay? So I'm going to make this next homework due after the quiz for you guys, just to make sure you guys can spend your time studying for the quiz. Okay, so this next lesson, let me start a stopwatch, make sure I don't take up too much of your guys' time. I'm going to set it for 50 minutes because class is usually 55 minutes. Okay, so 50-minute timer. All right, here you go. All right, we're going to talk about dividing polynomials. Right, so last semester we talked about adding and subtracting and multiplying polynomials. We skipped over dividing polynomials, okay? So there's three types here, which is up here in the learning objectives, okay? If we divide a polynomial by a monomial, it's actually pretty simple, okay? So here in the top of this example A, we've got this monomial, this polynomial. Got this right? It has three terms, so it's a polynomial. We have a monomial down here that there's just one term, okay? These aren't too bad. All you got to do, split the numerator up, okay? So what you're going to do is you're going to write that first term in the numerator over the denominator, okay? Plus, then we're going to do the second term, okay? That second term in the numerator all over the denominator, okay? And then, you guessed it, that third term in the numerator all over the denominator, okay? So we just basically rewrote these three terms up here as three different fractions, okay? We can do that, right? We can do that. We're allowed to do that algebraically, okay? And then all you got to do then is simplify these three terms, okay? This is going to be a little bit of review over the beginning part. I think it's up chapter 5, right? So this 3 over 3, that cancels, okay? These y's are going to cancel. Remember, x cubed over x, that's the same thing as x cubed over x to the 1. When we see that, we subtract the bottom exponent from the top. So it's, right, so this term right here, this first term, that x cubed over x simplifies to x squared. Then we're going to have a plus over here, right? That 9 over 3 becomes a 3. 9 divided by 3 is 3. Remember, guys, x squared over x, right? That's the same thing as x to the 2 minus 1. That's just going to be x. Likewise, y squared over y is going to be y. So this term simplifies to 3xy. Over here, the 3's are going to cancel. The x's are going to cancel. And then y cubed over y is going to be y squared. So we're just going to be left with a minus y squared. That's all we're left with, okay? So that's the solution to that first problem. So you just split apart the numerator and then simplify your terms. Start canceling stuff off. Subtract exponents from each other, okay? B, okay, same deal, okay? So we're just going to split up the numerator. So we're going to rewrite this as 8x to the 5th y over negative 4x to the 4th y plus 32x to the 4th y over negative 4x to the 4th y minus 16 x cubed y squared over negative 4x to the 4th y. Okay? Then we just go term by term simplifying everything, okay? So this first term right here, that 8 over negative 4 simplifies to negative 2, okay? X to the 5th over x to the 4th. Again, we're going to subtract the bottom exponent from the top exponent. So it's going to be just x to the 1 or just x. These y's are going to cancel. Okay, so that first term simplifies to negative 2x. Second term right here, okay? 32 over negative 4, that's going to simplify to minus 8. 32 divided by negative 4 is negative 8. X to the 4th over x to the 4th cancels. Y over y cancels, okay? So that second term just simplifies to minus 8. Over here, okay, we're going to have minus. And then 16 over negative 4 is minus 4. So, okay, minus 4, right? That just becomes plus positive 4, okay? So I'm going to actually get rid of that second plus sign. So it's just going to be plus 4. And then x cubed over x to the 4th, okay? X cubed over x to the 4th, that becomes 1 over x to the 4 minus 3, okay? Or just 1 over x, okay? So it's going to be plus 4 times 1 over x, and then y squared over y is equal to y, okay? So it's going to be times y. So let's rewrite this. I'm going to rewrite this term right here. I'm just going to rewrite it as 4y over x, okay? 4y over x, okay? All right, so that's all we do for that second example. All right. Good, okay. So that's the first way of dividing polynomials, okay? If we're dividing by a monomial, it's easy. Split up the numerator, simplify the terms, okay? Long division now. Let's move into long division, okay? So, you guys should have learned a long division in like 4th grade or something, okay? It's what we call an algorithm. An algorithm is a set of steps you can use to solve just over and over again to solve a problem, okay? So let's say I'm going to use a simpler example of long division. So let's do like 172 divided by 13. Let's try that, okay? What did we do? What did we do in 4th grade, okay? So we started with 13. We looked at our 13. We looked at our 172, okay? What we did was we started by looking at the first digit here, okay? We ask ourselves, does 13 go into 1 at all? No, it does not, okay? So what we did was we went to the next digit, that second digit of our the number that we're dividing, okay? 17. Now we're looking at the number 17, okay? Does 13 go into 17? Yes, it does. How many times can we fit 13 into 17? Once. So what we did was we wrote a digit 1 right above that 7, okay? So that was the first step in our algorithm. The second step is we take that 1 that whatever number we just wrote down, here it's 1, we multiply 1 times 13 times the number here on the left, okay? So I'm going to erase this line here real quick. Oh, gosh. All right. 1 times 13 is 13. I'm going to write that product right here. Okay, that was the second step. The third step was we subtracted these two numbers. Okay, the number that we just wrote underneath 17, we subtracted them. Okay, 17 minus 13 is 4. All right. The fourth step was we took this 2. This 2's just been hanging out right here. We haven't really done much with it. We just dropped it straight down. Okay. Just added it on. It's 42 now. Okay. And then we kind of repeat the process. All right. So let's start. 13. How many times does it go into 42? That's 3, right? Goes into 42 3 times. Okay. All right, and then that digit we just wrote down here, that 3, right, we multiply that by 13. 3 times 13 is 39. All right, we subtract them. 42 minus 39 is 3. Okay. All right, there's nothing left to drop down, so we're done with that. We're actually done with the problem at this point. We ask ourselves, does 13 go into 3 at all? No, it does not, so we're done. This 3 we have, that's our remainder. And the way we wrote the remainder in 4th grade was we did 13, and then what we did was you take the remainder and you write it as a fraction, okay? The 3 is in top, your remainder is in the top of that fraction. You put it up here with your answer. The denominator of that fraction is going to be whatever number you divided by. So here it's 13. So 172 divided by 13 equals 13 3/13. Okay? That was our answer back in 4th grade, okay? So that's just an example I wanted to talk about from grade school, okay? Because what we're about to do here, dividing polynomials by long division, right? It's a little different. It's a little more fancy, okay? But it's essentially the exact same process we did in 4th grade, okay? It's really pretty much the same thing, okay? So we're going to use that like box-like notation to rewrite this, okay? We're going to rewrite 5 x squared minus 17x plus 14, and then put that in a box, divided by x minus 2, okay? So we do the same thing here, okay? What you do is you start by looking at your highest degree term, and this is called the divisor, the thing that you divide by, the thing that's right after, the expression right after the division symbol, it's called the divisor. We look at that first term in the divisor, okay? We look at the first term in the divisor, and then we look at the first term in our dividend. Okay, that's the polynomial on top that gets divided. How many times does x, right, we start with this first term here. How many times does x go into that first term here in our dividend, okay? How many times, okay? That's the same thing as asking ourselves, it's a little different, right, with polynomials, okay? What I ask myself is, what do I have to multiply x by to come up with 5x squared? X times what gives me 5x squared, okay? Well, the answer to that is 5x. X times 5x equals 5x squared, okay? So what we do is we write this result here up, right, that number that we have to multiply x by to get 5x squared, we write it right above 5x squared, okay? That's our first step, okay? Very similar to what we did in 4th grade, okay? Second step. We take that 5x here, all right, and we multiply it by this whole divisor, okay? So we're going to do 5x, times x minus 2, okay? That gives us 5x squared minus 10x. What we do with that is we write it up here below these first two terms, okay? So we do 5x squared minus 10x, just like we did in 4th grade, just with x's and stuff, okay? All right, now what do you think we do? We subtract them, okay? I'm going to subtract those two terms I just wrote down from the two terms right above it, okay? So we're doing 5x squared minus 17x minus 5x squared minus 10x, okay? What I like to do, I like to change this to, what you can do is I like to distribute this negative and change it into an addition. So I'm going to rewrite this as plus minus 5x squared plus 10x. So as long as I change these two signs here, I can change this to a plus sign, okay? 5x squared plus minus 5x, that cancels, okay, that goes away. All right, and we're left with minus 17x plus 10x. That is minus 7x, all right? And then just like we did in 4th grade, we drop down this next term here, this plus 14, okay? All right, and then we do the same thing. We start with this first term, the highest degree term in our divisor, and we ask ourselves, how many times does x go into minus 7x, okay? Or what do I have to multiply x by to get minus 7x? Well, the answer is that x times minus 7 equals minus 7x, okay? So what I do is I write this minus 7 here as my next term in my solution, in my answer. So I write that minus 7 down, okay? Then I do an analogous thing like I did in the last problem. I take that minus 7 that I just wrote down, and I multiply it by everything in my divisor. I multiply my divisor by that, okay? So minus 7 times x minus 2, that's equal to minus 7x plus 14. And I'm going to take that, and I'm just going to write it right under here. All right? And again, I'm going to subtract that binomial from those two terms above it, those two numbers above it. Okay? All right, and so you can do the whole flip thing. We can make this like a plus 7x minus 14. Or you can just look at it and see, hey, I'm dividing a binomial by it, or I'm subtracting a binomial from itself, so my answer is just going to be 0, okay? So my remainder is 0 here, all right? Which means I don't have to write anything up here. I'd technically write plus 0 over x minus 2, but like that's just 0, so that just goes away, okay? So my answer here, and I'll highlight it in orange, is 5x minus 7, okay? So 5x squared minus 17x plus 14 divided by x minus 2 equals 5x minus 7, okay? So rewatch that, slow down, pause however many times you need to understand what's going on, okay? Next problem, it's going to be negative 4x cubed minus 8x squared plus 7x minus 1 divided by 2x minus 1, okay? Same thing, okay? We're going to start by looking at this leading degree term in my divisor, 2x, okay? We go to the first term in the dividend. We ask ourselves, what do we have to multiply 2x by? 2x times what equals negative 4x cubed? That what there is, so 2x times negative 2x squared equals negative 4x cubed, okay? So I'm going to take this number, the number I have to multiply 2x by to get negative 4x cubed. I write that right above 4x cubed, okay? What's my next step in my algorithm? I take this number and I distribute it among the terms in the divisor. So negative 2x squared times 2x is negative 4x cubed. Write that right underneath. Negative 2x squared times minus 1 is plus 2x squared, okay? And I'm going to subtract those two terms from the numbers right above it, okay? Again, let me make this a little smaller. I'm going to change this into a plus minus because I don't like doing subtraction. I prefer addition, okay? So negative 4x cubed plus 4x cubed, right? Those cancel, all right? Negative 8x squared minus 2x squared, that's minus 10x squared, okay? What do I do next? I drop down that next term, that plus 7x, okay? All right, and I repeat the process, right? So first, I look at that leading term in my divisor. I look at the leading term down here on my bottommost line. 2x times what is going to give me that leading term on the bottom? It gives me negative 10x squared. Well, 2x times negative 5x equals negative 10x squared, okay? So I'm going to write this result here, that negative 5x. I write it up here, minus 5x, okay? And then I take it and I distribute it, I multiply it by my divisor. So minus 5x times 2x is minus 10x squared, all right? And minus 5x times minus 1 is plus 5x, okay? So again, I take that, all right? What I'm going to do again is I'm going to subtract these two from each other, okay? And I like to change this into an addition problem. So I'm going to do plus, I'm going to do plus positive 10x squared minus 5x, okay? All right, so when I add these two terms, they cancel. And then 7x plus minus 5x is 2x, okay? All right, and I repeat the process, right? So look at this lead term of my divisor. Look at the, I forgot to drop down the minus 1. Drop down the minus 1. Sorry about that. There we go. But then I repeat the process. So 2x goes into 2x how many times? Or 2x times what equals 2x? Well, 2x times 1 equals 2x. So I write down a plus 1 up here. Plus 1 times 2x minus 1, that's 2x minus 1, okay? And then I subtract, right? 2x minus 1 minus itself, right? A number minus itself is 0, okay? My remainder is 0, so I don't have to write anything extra up here. All right, this is my final answer, minus 2x squared minus 5x plus 1, okay? That's my answer. All right, let's dive into C. Let's dive into C, okay? So we have 2n cubed plus 19n squared plus 30n plus 6 divided by 2n plus 3. Okay. All right, so we start, right? We look at that highest degree term, that leading term in our divisor. We look at that first term underneath our division symbol. Okay. We ask ourselves, how many times, or 2n times what equals 2n cubed? Well, 2n times n squared equals 2n cubed. So we write n squared right above our division symbol. Then we distribute the n squared. Okay, so we multiply both these terms in the divisor by n squared. It's going to give me 2n cubed plus 3n squared. Okay, and we subtract that product, that result. Okay? So we're going to do 2n cubed plus 19n squared minus 2n cubed plus 3n squared. Again, I like to change this into, let me get rid of this real quick. I like to change this into an addition problem, okay? So we're going to make this a plus, make that a minus, and then we've got to make that plus sign a minus sign, okay? So 2n cubed plus minus 2n cubed, those are going to cancel, okay? 19n squared plus minus 3n squared is going to be 16n squared. And then I've got to drop down this 30n, that plus 30n. All right. Now let's restart the process, okay? 2n, that lead term in the divisor, 2n times what equals 16n squared? So 2n times what equals 16n squared? That's what, 8n? 2n times 8n equals 16n squared, okay? So we're going to write plus 8n up here, all right? And then multiply everything in the divisor by 8n. So it's going to be 16n squared plus 24n, okay? Oh, whoops, get rid of all this. All right, and then we subtract these two from each other. Okay. So 6, right, and I'm going to change this into an addition, okay? So plus, minus, okay? So 16n squared plus minus 16n squared, that just cancels, it goes away. 30n plus minus 24n is 6n, all right? And then drop down that 6. And then repeat the algorithm one more time. 2n times what equals 6n? Well, 2n times 3 equals 6n. So we're going to take that 3 here, write it up above my division symbol, okay? Multiply 3 throughout the divisor. So 3 times 2n is 6n. 3 times 3 is 9, okay? We're going to subtract these two, okay? Again, I like to change this into an addition, so I'm going to make that a plus, and I can do this as long as I make this a minus, and then flip this sign as well, okay? So we're going to have 6n plus minus 6n, those cancel, and then 6 plus negative 9, that's negative 3, okay? Now we do have a remainder. Okay, I'm going to highlight my remainder in pink. All right, we're going to rewrite that remainder just like we did in 4th grade, okay? So we're going to attach, we're going to do a plus, well, in this case it's going to be a minus. We're going to do a fraction up here. The fraction of that, the numerator of that fraction, so there's going to be a fraction up here. The numerator is always the remainder. So we're just going to copy that negative 3 remainder up here, okay? The denominator is always the divisor, what we divided by, so 2n plus 3, okay? And that's my answer. That's how I deal with the remainder. So the answer to this problem is n squared plus 8n plus 3 minus 3 all over 2n plus 3, okay? That's my final answer. Okay, so slow down, pause, rewatch it if you need to, okay? All right, let's go for problem D. Problem D, okay? So something I need to point out, okay, we're gonna do this the exact same way we've done these other problems, but notice like there's an x cubed term here. Let's look at the numerator. In the numerator, there's an x cubed term, there's an x squared term, there's a constant term, but there's no x term, right? There's no term with just a regular old x in it, okay? What we've got to do is when we're setting up our division problem and we're writing out that top fraction, we've got to write in a 0x, okay? You've got to write in, for any missing terms, you just got to write them in as 0 times that missing variable, okay? You just got to do that, okay? If you don't, the algorithm won't work, okay? So that's a really important detail, okay? Write that down, okay? Write in missing terms as zeros, okay? All right. Okay. So let's go. So it's actually the same deal, okay? So we're going to start with this leading term in the divisor. 6x times what? 6x times what is going to give me that 12x cubed, that first term under the division symbol? All right, well, 6x times 2x squared equals 12x cubed. So we're going to write 2x squared up here on top. All right, then let's take this 2x squared and multiply out this binomial, okay? So 12x cubed minus 4x squared, okay? I just multiplied the term I just wrote down on top by the divisor, wrote that result down here. Then I'm going to subtract these two, okay? All right, again, I can change this to a plus as long as I flip these two signs, okay? 12x cubed plus minus 12x cubed, that just goes away. 32x squared plus 4x squared, that's 36x squared, okay? There we go, drop down my plus 0x. All right, and then begin again, okay? 6x and 36x squared. 6x times what equals 36x squared? Well, 6x times 6x equals 36x squared, okay? So we're going to do a plus 6x up here. And then again, multiply through. 6x times 6x is 36x squared. 6x times minus 2 is minus 12x. Okay. All right. Subtract. Do your subtraction. Okay. So we can change this to a plus as long as we flip these two signs. 36x squared plus negative 36x squared, those cancel. 0x plus 12x is 12x, okay? And then let's drop down this minus 3 up here. All right? Repeat the algorithm one more time. 6x times what equals 12x? Well, 6x times 2 equals 12x, okay? Let's take this 2 and distribute it. 2 times 6x is 12x. 2 times minus 4, or minus 2 is minus 4. Subtract. Okay, so let's change this to a plus. Flip these signs. 12x plus minus 12x cancels. Negative 3 plus 4 is 1. All right. So we got to include the remainder up here by doing plus, and then our fraction is going to be the numerator of that fraction is always the remainder, so 1. The denominator is always the same as the divisor, what we divided by, so 6x minus 2, okay? So here's my final answer. There you go. Okay? So that's D. Rewind, pause, slow down if you need to, okay? Here's another very similar problem, okay? I'm going to go a little faster through this one since we've seen it a few times, okay? Remember, right, we've got an x cubed term in our numerator, an x squared term, and a constant term. We're missing an x term, a term with just an x variable in it, so we got to write that in, okay? So 4x cubed minus 6x squared. I've got to write in my plus 0x and then my plus 1, okay? That's divided by 2x plus 3, okay? So let's start with that leading term in my divisor, 2x, okay? 2x times what gives me that 4x cubed, that first term under the division symbol? Well, 2x times 2x squared equals 4x cubed. So we're going to write a 2x squared up here. Okay? We're going to multiply this 2x squared through the divisor. So 2x squared times 2x is 4x cubed. 2x squared plus 3 is what? Plus 6x squared? Yeah. Yeah. Okay, cool. Then we're just going to subtract. Okay. Let's change this to a plus sign. Flip these two signs. I like to do that. Okay, so 4x cubed plus minus 4x cubed is 0. Or that cancels. Minus 6x squared plus minus 6x squared is minus 12x squared. Drop down the 0x. So plus 0x. Okay. Let's restart. Let's do the algorithm all over again. 2x times what equals minus 12x squared? 2x times what equals minus 12x squared? Well, 2x times, what is that? Minus 6x equals minus 12x squared. So I'm going to take this minus 6x, write it up here, minus 6x. Okay. Then we take what we just wrote down and we distribute it through the divisor. So minus 6x times 2x is minus 12x squared. Okay. Minus 6x times 3 is minus 18x. Okay. Subtract. Do your subtraction. Okay. So let's make this, change this into a plus, then flip these two signs inside the parentheses. 12x squared minus 12x squared plus positive 12x squared, that cancels. 0x plus positive 18x is 18x. Okay. All right, then we drop down the 1, do the algorithm one more time. Okay. 2x times 9 gives me 18x, so I'm going to write a plus 9 up here. All right, then multiply that 9. 9 times 2x is 18x. Okay. And then 9 times 3 is 27. All right, do some subtraction. All right, let's change this to a plus, minus, and then a minus. Okay. So 18x plus negative 18x cancels. 1 plus negative 27 is negative 26. Okay. And then 2x does not go into negative 26 at all. As soon as your remainder has a smaller degree, right? So the degree of a constant term like negative 26 is 0. As soon as the degree of your numerator, of your remainder right down here is less than the degree of your divisor, you're done, okay? And we just write that remainder as minus 26, that remainder over 2x plus 3. The remainder over the divisor, okay? So that's going to be my answer. There we go. Okay, so pause, rewind, slow down. How much time do we have left? About 16 minutes. That should be enough to do these 5 synthetic division problems. Okay, synthetic division is, a lot of people find it a lot easier, so good for you guys. You're done with the hardest part, okay? So here's how this works. It's a little easier than long division, okay? The one caveat, okay, you can only use synthetic division when your divisor, that polynomial that you're dividing by, when your divisor has a degree of 1, okay? So that's the drawback. You can only use it, it says use it when your divisor, so if divisor, that's going to be your polynomial on the bottom, the polynomial you're dividing by. If there's any exponent in here that's 2 or greater, you cannot do synthetic division. Otherwise, it's a great tool. Okay? All right. Here's how this works. So first of all, first thing you want to do is you want to rewrite the top with any missing terms. There's not a missing term here, so it doesn't really matter. Okay. All right. So we don't have to do that here, so I'll show you that on another example, okay? What you do is you write out, let's look at the coefficients of the top. So that's 1, -4, -45. You write those out, okay? So 1, -4, and -45, okay? These three numbers here, 1, -4, -45, that came from my coefficients up here. 1, -4, and -45, okay? So you write those out, okay? And then you draw a little box here, all right? Mr. Miller calls it the crow's nest, little box, okay? In that box, what you do is you go down to your divisor, okay? You look at this constant term in your divisor. What is that here? Here it's -5, or it's +5. What you do is you write the opposite of that number in the crow's nest, so -5, okay? -5. Then you draw a little line here, leave a little bit of space, and you draw a little remainder box, okay? The number that's left over at the end in here is your remainder. So let's do, this is going to be the remainder box. Okay? Here's how this algorithm works. Okay, it's very simple once you get the hang of it. It's actually pretty simple to get the hang of. Okay? We're going to take this 1, we draw a little arrow, we just copy the 1 down right here. Okay? When a number appears down here in the bottom, we multiply it by -5 and write that result underneath the next number. So -5 times 1 equals -5. Then we add along this column. -4 plus -5 is -9. All right, continue. -5 times -9 is 45. We write that result here. Add. -45 plus 45 is 0. Okay? So here's my remainder. My remainder is 0, so I don't have to worry about that right now. These two numbers, these give us our answer. Give us our answer. Okay? These are actually, I should say, a more precise way to say that is these are the coefficients. The coefficients of our answer. Okay, so it's in ascending degree term. So so go from right to left. Go from right to left. Okay, to write down the answer, you just this first number here to the left of the remainder box. You're just going to write down -9. That's our constant term. This 1 is our x term. So it's going to be 1x minus 9. That's our solution. That's our answer. Okay, so that's all you do. Okay, let's go to B. Okay, first thing we do, we're going to look at the coefficients of our top polynomial. Okay, so we're going to write down 2, let me do this in blue, 2, -9, and -35. We just write down those coefficients. Okay, draw a line, do your remainder box, and don't forget the crow's nest. Okay, crow's nest right here. In the crow's nest goes the opposite of this number, that constant term of your divisor. That's -7. What's the opposite of -7? +7. Okay? +7. Right? Okay? So again, we start out, we just draw an arrow underneath this 2. We just copy the 2 down there. All right, so then it's multiply, add, multiply. So we're going to multiply 7 times 2. That gives us 14. We write that in the next empty space. Add, -9 plus 14 is 5. Excuse me. Now multiply again. 7 times 5 is 35. Add again. -35 plus 35 is 0. So there's no remainder. All right, there's no remainder in our remainder box. And here are the coefficients of our answer. So this 5 on the right is my constant term. This 2 right here is going to be my x term. So I have 2x and then a positive 5. That's my solution. That's my solution, okay? All right. Let's move on to C, okay? Now, this one's a little more relevant, okay? Because, so in my dividend, in the polynomial that I'm dividing, there's an x to the 4th term, an x cubed term, an x term, and a minus 2. Right? We're missing the x squared term. We're missing that. So we've got to write that in. We're doing 2x to the 4th plus x cubed plus 0x squared minus x minus 2, all right, divided by x plus 1, okay? So I'm just writing in that 0x squared right here to help illustrate my point, because what we've got to do when we set up our synthetic division, we're not just going to write out 2, 1, negative 2. We're not just going to skip that 0, okay? We can't do that. We're going to write out 2, right, that coefficient 2, 1, because there's a coefficient of 1 right here. We're going to write 0, because there's a coefficient of 0. We're going to write negative 1, because there's a coefficient of negative 1 right here. And we're going to write negative 2, because there's a coefficient of negative 2 right here in our dividend, okay? All right, so I wrote out this 0x squared to illustrate why you have to have this 0 here, okay? All right, what number is going to go in our crow's nest? So it's going to be the opposite of this constant term here in our divisor. That term here is plus 1. Oh, gosh. So we're going to put a minus 1 in my crow's nest, okay? Draw a line, and that last column gets our remainder box, okay? Cool. Now we do the synthetic division algorithm, okay? Draw an arrow down here. Copy the 2. Again, multiply, add, multiply, add. You just alternate. Negative 1 times 2 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times negative 1 is 1. 0 plus 1 is 1. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. And negative 1 times negative 2 is positive 2. Negative 2 plus 2 is 0. Okay, so there's no remainder again. And then my answer, right, we're going to start with this term on the right. That's my constant term, negative 2. And then I have a 1x, a plus 1x, okay? Right here, that next minus 1 gives me a minus 1x squared. And this 2 in front is a plus 2x cubed. So here's my answer. 2x cubed minus x squared plus x minus 2. All right, there you have it. Okay, there's no remainder. Don't have to worry about writing a remainder down, okay? Good stuff. All right, part D. Part D. Okay. Woo! Notice, okay, there's a lot of missing terms, right? So there's an x to the 4th, and there's a constant term. We're missing the x cubed, x squared, and x terms, right? So we've got to put in zeros for all those. So I'm going to rewrite that numerator, that polynomial on top, as x to the 4th plus 0x cubed plus 0x squared plus 0x plus 16, okay? And this is still divided by x minus 2, okay? And I do that, right, to show you guys, this is a coefficient of 1 here technically. I do that to show you guys when I set up my synthetic division, I have to write out these coefficients as 1, 0, 0, 0, 16. Okay. What's going to go in the crow's nest? Right, so this constant term in my divisor is minus 2. The opposite of that, positive 2, goes in my crow's nest, okay? Draw a little line, a little remainder box in the last column, okay? Let's do our synthetic division algorithm, take the 1, drop it down here. Okay. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. Okay. And 16 plus 16 is 32. Okay. So let's worry about, I'm going to highlight the remainder in pink. Let's worry about that at the end. Okay. Let's worry about that a little later. Oh gosh, I can barely see that. I'm not going to highlight it in pink. I'm going to highlight it in, let's do blue. Okay, that's a little better. Okay, so my answer then, right, going from right to left here, we're going to have plus 8. That 8's my constant term. The 4 is going to be the coefficient of the x term in my answer. The 2 is going to be the coefficient of the x squared term. And the 1 is going to be the coefficient of the x cubed term, okay? And then again, we actually deal with the remainder the exact same way we did in the long division, okay? So we're going to write the remainder as a fraction. It's going to be plus the numerator, okay, as a fraction. The numerator of the fraction is just whatever my remainder is, so 32. The denominator is going to be whatever I was dividing by. So I was dividing by x minus 2 here, so it's going to be plus x minus 2. Here's my answer. All right, that's it. All right. Let's do E real quick. E, okay. This one's not too bad, right? There's no missing terms in my dividend. All right, so the way long division works, I'm going to write down the coefficients of my dividend. So 10, 80, and minus 8. Let's set up the crow's nest. What do I put there? I put the opposite of this number that's in the divisor. So minus 8. Okay, draw a line, draw a remainder box. All right, now start. Just copy down the 10. Negative 8 times 10 is negative 80. 80 plus negative 80 is 0. Negative 8 times 0 is 0, and negative 8 plus 0 is negative 8. Okay, so my answer here, right, that 0 is my constant term. That 10 is my x term, so it's 10x plus 0. Okay, let's just ignore the plus 0, so I'm going to get rid of that. And then my remainder here, right, I've got a remainder. I'm going to write that as a minus 8, that remainder over whatever I was dividing by, so a plus 8. That's it, folks. I'm finished. Okay. I guess it should be an A, right, instead of an X. Sorry about that. 10A. Sorry. That's it, though. So, okay. So this actually we'll see as a way to find out the slant asymptotes when I have slant asymptotes of rational functions. Okay. So slow down, pause, go back over this video. I'm going to be available on Zoom today from, I'm thinking 9 a.m. to 3 p.m. So send me an email if you want to hop on Zoom and talk about this. I forgot to bring the textbook home with me. But luckily, this homework's not going to be due until after your quiz. Okay, so I'll post the homework. Well, I already posted the homework problems. So if you've got the textbook at home, you can start on it. But you guys will be able to get the textbook problems, and I'll post the textbook solutions right before our quiz. So you can just start working on this homework after our quiz. In the meantime, it's probably a good idea to just study for the quiz anyway, okay? So take care, guys. Email me if you have any problems or are really stressed or anxious. Take care.